In this activity, we're going to focus on Learning Objective 4.1a, which is going to help us define what a radian is. So what we're ideally going to need is a blank sheet of paper, a pencil, some type of straight edge, and a compass to draw a circle, and then a pack of candies. In particular, we're going to use Smarties for this activity. So the first thing you need to do is take your candy object and take 7 of those pieces. And we're going to put all 7 pieces side by side. After that, we're then going to take the length of the 7 pieces and draw a line segment, which will represent the radius of a circle for that. Then remove the candies, and then we're going to use a compass to make a circle where this black line here represents the radius of the circle. So the image I've drawn here would be an ideal type of circle. Now we're going to actually remove the 7 candies, but we have the circle drawn on our piece of paper. Now take your 7 candies and line them up starting at where the radius was drawn. And notice how I put the candy on here. It's right smack dab as much through the diameter of the candy as possible. And you're going to take all 7 candies and put them side by side. And once you're done laying these down, you're then going to take your pencil and tick mark where the last candy ended. Now, take the 7 candies that you had here, remove them, and then place them around the circle again, tick mark, and continue to place them around and tick mark. Your goal is to see how many different times did it take you to lay out the one string of Smarties. Now, before you do that, let's talk about what this one string of 7 Smarties represents. Remember, this string of our 7 candies came from the 7 candies laying out here. So what we actually just did now is this distance right here is 1 radius of the circle. And in trigonometry, what we actually call that is 1 radian. So what we're noticing here is if we take the radius, which was right here, and we lay it out on the outside of the circle, what we created, again, we call 1 radian movement. So the ultimate question is, how many radians will it take for us to go on the circle from the start all the way back to the end? So conduct the experiment and see how many radians it takes you. Now, what you ultimately should have noticed is if we started here, it's going to take about 6 of these lengths to get me to about right here. And then we're going to have a little bit left over. So the question is, how much is left over? Well, if you take your other Smarties, you're going to end up noticing you can lay about two more extra Smarties around. So what it's taken you is 6 radians and then 2/7 of that last string of the Smarties. So what this is it's going to be 2 6/7 radians to get around the circle. Now what you want to take away from this lesson is to be able to do 1A. What would you define a radian as being? And a good definition would be is the length of the radius on a circle. Now let me ask this. If we did our activity not using something other than Smarties, what if we took 7 tires and we lined 7 tires up, drew the radius, and then made a huge circle with all 7 tires? And then we laid the 7 tires out and tick mark, 7 tires and tick mark. How many lengths of the 7 tires would it take to go around the complete circle? Well, the answer is going to come back the same. It's going to be 6 and then 2/7 of the tires at the end. So it doesn't matter the size of your circle. Okay. Now, let's look at 1B. Approximate how many radians goes around the circle. So 6 and 2/7 is a fraction, so I'm going to do approximately. If you put 2/7 in the calculator, we're going to get this to be about 6.28. So it's approximately 6.28 radians, or radii measurements, to go around a circle. You know, what is the distance around a circle related to? Well, it's related to circumference. So it's related to C equals 2 pi r, which is the circumference or the distance around a circle. So the question 1D wants to know exactly how many radians go around a circle. Well, to figure this one out, we can use this formula. So my question here is, circumference would be equal to 2 times pi. Now we had our circle and we had this length. So what is the radius in this case? Remember what we did is we took this one length of the radius and we laid it out here, and that was 1 radian. So what we have here is the radius. I don't want to say Smarties or candies. It's actually just 1 radius. So the radius on this is 1. So I'm going to put that in here. Well, the circumference, therefore, is going to be 2 times pi. Now, if you put 2 times pi in your calculator, that's going to be approximately 6.28. So what we can glean from this is 2 things. There's approximately 6.28 radians when you go around a circle from start to finish. That means you can lay the radius out that many times. But there's exactly 2 pi radians. And in Chapter 4, that's how we talk, is in terms of pies. So we're going to start saying how many pies does it take us to go around a circle. And when we talk about the pies, we mean radians, or how many times the radius is laid out on the circle. Okay, let's conclude this with a few other discussion points. How many degrees are in 1 radian? Well, think about a full circle. We know a circle, if we start here from start to finish, a full circle is 360 degrees. We know we did approximately 6.28 radians to go around this circle that way. So why don't we take 360 degrees and divide it by 6.28 radians? If we do that, we're going to get that there's approximately 57.3 degrees in 1 radian movement. So what you've noticed is we've just talked about radians in relation to degrees. Well, we're going to add a third thing. We're also going to talk about revolutions. So how many revolutions is there in 1 circle? Well, if I go to this circle and I go around the circle once, that is 1 revolution. So there's 1 revolution, which is the same as 360 degrees, which is the same as approximately 6.28 radians. 3b wants to know how many revolutions in 1 radian. Well, remember, we just said 1 radian was about this length. It's also about 57.3 degrees. Well, how many revolutions is that? Well, one way you could do it is say this. You could say there's 57.3 degrees in our 1 radian movement here, but a full circle is 360 degrees. So if you simplify this, you're going to get 0.16 revolutions. So based on that, we can conclude this. There's approximately, again, 6.28 radians to go around a complete circle. 1 radian movement is about 57.3 degrees. 1 radian movement is about 0.16 revolutions of a circle.